Corporate finance practice problem using OneNote. We will get into a bit more detail about the calculation of the bond rate, think about the bond rate and the effect on the bond price, change the bond rate, and then look at the impact in the bond price. Get ready. It's time to take your chance with corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we're going to be in the icon on the left-hand side in the practice problems down in the 1023, calculate bond rate and change in rate tab. Also note that when using OneNote, you might want to take a look at the immersive reader. Many of our presentations will also be in the text items down here, same number, same name. The text items being transcripts that can be translated into multiple different languages and both listened to and read in those languages, thereby being a good complement to the presentations up top. Closing out the tab to the top, we then have our information up top, and we have that calculation on them that will be down below, like problems in the past dealing with present value type calculations. We will do the calculations in multiple different ways typically. So our issue is going to be up top. We have the issue or the problem of issue bonds in the past. Bonds were issued 5 years ago. The par value is going to be the 1,000. The life is going to be the 20 years. The life, we're going to assume annual payments on the bonds. Then we have the calculation of what we believe the rate should be. Note that when the bond is issued, then you might be thinking, I want the rate to be the market rate so that I could sell the bonds for the $1,000. If the market rate and issued rate were the same, that would then be the case. It's actually a little bit difficult to realize that, to think through that when we start to do these present value calculations. So we'll actually do the present value calculation with that being the case, meaning market rate and bond rate being the same, and we'll get to that $1,000. Then we'll do a change, see a change that happens, and see what the alteration or change will be on the price. So note, when thinking about what the market price will be, it's not as easy oftentimes as just simply saying, well, the market says the price should be this, because if we're a corporate bond, we have to kind of think about where we stand with relation to similar bonds to us and make the determination of bonds in our class using the class ratings and whatnot, how much risk should be out there to determine what a proper or efficient price would be for us to sell our bonds on the market. Might look something like this. You'd get into more detail with these categories, which could include the real rate of return, the inflation premium, and the risk premium. These are some categories that may be considered in order to then get to the total amount that would be the rate of the bond. When issuing the bond, we then might come up with this rate and try to match what the market rate would be so that we could sell the bonds at the face amount. Note that after the bonds are issued and you're thinking about purchasing or selling bonds, then you do the same calculation most likely, and then try to figure out whether or not the market rate matches the bond rate and what price you would then think about either selling or purchasing a bond at, and then think about a premium or discount. So first, we'll actually calculate this out as if the bond was issued at 17% and that was an accurate calculation of the market rate and bond rate being the same. Then we'll talk about a situation where the inflation is now changed. So we're going to say the inflation was 5 before, now it's 3. So what would be an appropriate price on the market given the fact that now the rate is going to be less than it was before? It's now going to be, 2% less, or 15. So the bond rate will then be 17, the market rate will then be 15. In that situation, note what will typically happen in terms of a discount or premium. If the bond rate is higher than the market rate and we were trying to sell the bond, we're going to have the advantage and we'll sell it basically at a premium. So then we're going to calculate it and see that there should be a premium, but what exactly would that premium be given these circumstances? First, let's start off calculating the bond price using the 17% for both bond rate and market rate. So we'll do two calculations. There are two components like we've seen in the past. We're going to have the annuity portion, which is going to be the 1,000 times the bond rate, 17%, and then the present value of 1, which is going to be the 1,000 times the 17.2, because we're going to be the present value of an annuity, which is going to be taking back the 1,000 using the present value calculation, and 17% given the fact that that will also be what we will consider to be the market rate. Annuity calculation looks like this. The P times 1 minus 1 plus R to the negative N. So P times 1 minus 1 plus R to the negative N. P then is going to be the 1,000 times the 17%, 1 minus 1 plus R 17%. To the negative n, we're going to say 20 over r, which is going to be the 17% again. So we'll do that in a little table type of format. We've got the p, which is going to be the 1,000 times 17%, or 170, then 1, and then that's going to be the numerator, then 1 plus r. I'm going to pull into its inner column 1 plus the rate, 17%, this now being the market rate, which is the same for our first problem. The 1 plus the 17%, or 100% plus 17%, 117, to the power of the number of periods, negative number of periods, in this case years, that being 20. So to the negative 20 is going to give us our calculation to the right. Let's go ahead and do that with the calculator, noting that we do need to have a calculator that can take it to the power of negative 20. For us, I'm going to change the standard calculator to the scientific calculator and do the scientific like. So there's the 1 plus the 0.17, 1.17, or 117%. And then we're going to take this to the power of negative 20, which is this x to the y. X to the y, that puts the caret up top. It needs to be negative. So I'm going to hit this little negative button down here. I'm sorry, that wasn't right. Let's do this again. Clear that, start it over. So I've got, let's clear the whole thing. Clear the whole thing. We're going to say 1 plus 0.17. That's going to be the 1.17 x to the y. There's the caret. Then I'm going to type in the 20 and then put in the negative for the negative 20 and equals. That gives us the 0.0432 and so on. I'm going to switch back to the standard calculator now. Standard calculator. Pull that up top. Now we're going to complete the numerator 1 minus that thing we just got to. That's going to give us the numerator 0.9567245. The denominator simply is 17. That's going to be the rate. So now we can take the num divided by the denom, and that's going to give us this 5.6277. That's 0.9567245 divided by 0.17, and making that a little bit larger. We got the 5.6 and so on. Taking that, multiplying times the 170 times the 170, we get the 956.72 and so on. So there's the present value of the annuity. Then we need the present value of the 1,000. But before we get there, we're going to calculate this one a few different ways. So we can also do this with the Excel function, which would look something like this. Present value, then the rate. The rate is going to be that 17%. That would be the market rate, which is the same as the rate on the bond for this first calculation. And then the number of periods, that's going to be then 20. We're going to start it out for. Then comma, and the payment amount would then be the 1,000 times the 17%, or in other words, the 170 we got up top. That also gives us the 956.72, this way being the easy way. Then we can do it with the tables if we needed to, but before we do that, let's do a running balance calculation. We can break down the annuity into a running balance, 20 periods, present value of 1 each period. So we can do that process. The first payment, 170, which if we bring back, present valuing it would be 145. Second payment, 170. If we bring it back to the first year, and notice I'm not doing the present value calculations here. We do this in Excel. If you want to see this running balance calculation, we will see a present value calculation when we do the second component, bringing the 1,000 back. But just note that you can do this process fairly easily in Excel. That would be the 170, would be 124. 124 plus the 145 gives the 269. Third payment, 170, bringing it back 3 periods, would be 106. 106 plus the 269 gives us the 376, and so on. Taking that down to the bottom 20 periods, that gets us once again to the 957. That this time rounded, no cents, no pennies being added here. We could also take the present value of the 1,000 and tack that on, also 20 periods out, if we were to present value it using Excel, magically getting the present value of the 43. 43 plus the 957 about gives us that 1,000, the answer we would expect to get if the rate on the bond was the same as the market rate, which it often would be if when we first issue the bond. So just to note that we can calculate that, and that would be the case, which again, is not quite as intuitive when you do these present value calculations that you'll get to that 1,000. Now we could get to this 957 with tables, possibly too, but I'm going to skip that process now. We're going to go to this 1,000, the second component, recalculate this, get into the 43 in another way, first using the present value calculation. This being the present value of 1 for that 1,000. So we have the present value of the future value. We can think of it as over 1 plus r to the n. Future value being the 1,000, 1 plus r then being the 17%, which we're considering both the market rate. In this case, the market rate is what we're considering, but it's the same as the rate on the bond. To the n, which would be 20 periods. Let's do that with our little table here. We got the 1,000 in the outer column. 1 plus r to the n is going to be 1 r 17%. That's 117%. Taking that to the power of n. 1.17 or 117% to the power of 20 is going to give us 23.105599. Then if we take the num divided by the denom, or the numerator over the denominator, the 1,000 divided by the 23.105599, we get that 43.28 again. Adding that 43.28 to what we got when we did the annuity calculation, in other words, the 956.72, that then gives us the 1,000 end result, what we would expect if, and in this case that, the rate on the bond is the same as the market rate. So let's do this calculation again, this 43.28, the easy way, Excel way. So we would have the present value equals the rate, which would be that 17%, comma, number of periods, which would be then 20, comma, because it's not a payment, it's going to be a payment of one, not an annuity. Future value then the 1,000, that also gives us the 43.28 again. So there's the first one. We get, if we have the same rate, then we're going to be getting to the same result of that 1,000. That would be what we'd sell it for. But we'd have a similar kind of calculation if at a later point in time we then said, okay, now there's been a change to this calculation. Time has passed and there has been a change. The bond has served us well as time has passed, but now the inflation is now 3% instead of what we thought before, 5%. So if we had a situation where we wanted to sell or purchase this bond now, we have a difference. We'd have to say, well, what do we think the market rate is now? It's going to be something different. It's going to be the 6% plus the 6% plus the 3%, which is 15%, or you can take the 17 minus the 5 minus the 3 is 2, so minus 2, 15%. So now it's 15%. The market rate is 15% now. The bond rate doesn't change because we issued the bond 5 years ago. It's still on there at the 17%. So now the bond rate is higher than the market rate. If we were selling the bond at that point, then now we have a situation where we're kind of in an advantage. If we go on the market and say, hey, we got these bonds out there, you're not going to find a bond like our bond where you're going to get 17%. You can only get like 15% for bonds similar to our bonds. Therefore, we're going to sell our bonds at a premium. So we expect there to be a premium here at some point, meaning price over the 1,000. Then what exactly would that premium be? That's when we have to do the calculation. Let's do it. We're going to do the present value of the annuity first, and then the present value of 1. Annuity, P, which is going to be the 1,000 times the 17% still, because that's the rate on the bond, times 1 minus 1 plus R, which is now 15% because of this change. That's the market rate, to the negative N, which is now 20 minus 5, because 5 years have passed, or 15, negative 15, divided by R, which is now once again the market rate 15, as opposed to the 17 market rate. So if we put that into our table, 170, which is the 1,000 times the 17, the rate on the bond, then the 1, that's on the numerator, then the 1 plus R to the N, which is going to be 1 rate on the market rate, now 15, that because of this change here, the 17 minus the 2% being the 15, then 1 plus 0.15 is 1.15 or 115%. To the power of the negative periods. 5 years have passed, there were 20 periods, and now like 5 years have passed. So there's only 15, 20 minus 5. So if we take the 115 to the negative power of, or the power of negative 15, we get the 0.122894449. Then 1 minus the 0.122894449 gives us the 0.877105551. That being the num, or numerator, divided by the denom, or denominator, which is now the market rate, which is no longer 17, but changed to 15. So that's the 15% again. The num divided by the denom, numerator over the denominator, gives us the 5.8473710. and then the 170 times that number gives us the 994.05. That then, the present value of the annuity portion. We then need to get the present value of 1, the 1,000. But before we do, let's do this one a few different ways. Next, the easy way, Excel way, that's going to be present value. We got the rate, which would now be that 15% market rate, the 17 minus basically the 2%, 15%, comma, number of periods, which would now be 15, which would be the 20 minus the 5, 15 periods. That's why we have a subtraction thing there, comma. And then the payment would be still same, 1,000 times the rate on the bond, 17% for the 170. That then, if we put that into Excel, would give us magically Excel way 994.05. Then we could do this with a present value calculation, breaking all of the 15 payments now down into present value of one at a time. In other words, taking that first 170, present valuing it using Excel, doing it magically, would give us the 148. The second payment of 170 in the annuity, because it's an annuity and these payments are all the same, would be pulled back to a present value 2 periods out of 129. The 129 plus the 148 gives us the 276. Third payment of 170 would be pulled back 3 periods to give us 112. 112 plus the 276 gives us the 388, and so on and so forth for 15 periods, which would end off after those 15 periods of 994 without the pennies. Again, same number we got to prior, but no pennies. We can also tack on in a similar fashion as we're just doing this the magic way and say, why don't I just pull in that 1,000, which is also now 15 periods out. Now, if it's only 15 instead of 20 periods out, it is worth present value, the 123. That 123 plus the 994 now adds up to what we would consider the price of the bond to be, it now being higher than the value, the 1,000, not because 5 years have passed, by the way, but because the rate is now different after that point in time. Market rate now demanding, or market rate only being able to find 15% similar bonds as opposed to the bond rate on the bond, 17, resulting in it having a premium price that would be higher. It would be sold, in other words, for a price higher than the face amount or par value. Let's calculate this one again, not the magic way, but formula way for the 1,000, present value of 1 formula. PV equals future value, 1,000, over 1 plus R, now the market rate, 15%, as opposed to the 17, to the N, number of periods, now 15, 20 minus 5. Let's do it with our table then. We've got the 1,000. 1 plus R to the negative N is going to be 1, R, 15%. 1 plus 0.15 would be 1.15, or 115%. And then we'll take that to the power of N. Number of periods was 20, but now 5 years have passed. So 20 minus 5 is 15. And then we got the 115% to the 15 power gives us 8.1370616. And if we take the num, 1,000 divided by the denom, 8.1370616, we get the 112.89. If we add that 112.89, which is the present value of 1, the 1,000 at the end, plus the 994.05, the annuity we got to last time, we get to, again, that 1,116.95, which is the price that we would expect of the bond at this point in time. It also, of course, higher than the 1,000 par value due to the fact that we're issuing it at a premium, because the rate on the bond is higher than the rate that you can get on similar bonds in the market. Let's go ahead and calculate this 122.89 again, this time the easy way, the Excel way. So we're going to take the present value and then brackets the rate, 15%, not 17, but 15, the new market rate, comma. Number of periods would then be 20 minus 5, 15, comma, comma, because it's not an annuity. Future value then being the 1,000 times the 17%, the rate on the bond, which would give us, of course, that, comma, comma, the future value would just simply be the 1,000, not the payment. That would be the annuity. So once again, rate, 15, market rate, comma, number of periods, 15, comma, comma, because it's not a payment, future value, the 1,000. That then would give us the 122.89 again.